Imagine, just for a moment, if this pressure valve could predict its own failure, next Tuesday perhaps? And what if this chemical reactor could autonomously discover the ideal temperature and flow rate to cut energy costs by 20%, all on its own? You know, this isn't science fiction. This is what we call machine learning, and it's quietly sparking a revolution in the world of industrial instrumentation engineering. We're moving beyond merely reacting to issues. We're stepping into an era of predicting and optimizing. All right, let's break it down a bit. So, first things first, a quick refresher. For the past 50 years, instrumentation has served as the nervous system of any plant. It's all based on a simple loop: measure, compare, control. So, this traditional system is great at one thing: maintaining stability. If the flow drops to 90, the controller says, open the valve more. It's all based on simple, pre-programmed rules. But, you know, it has a huge blind spot. It only reacts after a problem has started. Now, here comes machine learning. Instead of just looking at one sensor, ML models can analyze thousands of data points from all sensors at once. They don't just follow rules, they learn patterns that are honestly too complex for any human to see. Here are the three biggest uses. This is the big one. Traditional systems wait for a pump to fail, causing an expensive, unplanned shutdown. An ML model, however, monitors subtle changes in vibration, temperature, and power draw. It's learned the healthy signature of that pump. When it sees a tiny, weird pattern developing, it can say, this pump's bearing is 95% likely to fail in the next 7 to 10 days. That's the difference between emergency stop and a scheduled, low-cost repair. This is ML's Spidey sense. Imagine a complex process where temperature is fine, pressure is fine, and flow is fine. A human operator sees all green lights, but an ML model, which has studied months of data, says, wait, these three specific values, at these exact levels, have never occurred together before. This is an anomaly. This could be the subtle first sign of a tiny leak, product contamination, or a serious safety risk, letting you catch it before it becomes a disaster. How do you run a boiler to get the most steam for the least amount of fuel? It's a massive equation. ML models can test thousands of virtual scenarios to find the absolute perfect settings for every valve and heater, squeezing out extra efficiency and cutting energy bills. And what about soft sensors? Let's say you need to know the chemical purity inside a reactor, but installing a physical sensor is impossible or costs $1 million. An ML model can infer that purity with 99% accuracy just by reading the other sensors, like temperature and pressure, effectively creating a reliable virtual sensor for free. The future is even smarter. We're moving machine learning models out of the central computer and onto the sensors themselves. This is what we call Edge AI, and it lets the instrument make decisions in just milliseconds without even needing the cloud. And, you know, this all feeds into the digital twin, a perfect live simulation of the entire plant. Here, you can use machine learning to ask, what happens if we try this new raw material, and see the result, risk-free, before you change a single thing in the real world. So, machine learning isn't replacing instrumentation engineers, it's actually giving them superpowers. It's changing the job from fixing what's broken to predicting what will break, and optimizing what already works. The sensors and valves are still the heart of the industry, but machine learning is the new brain. Thanks for watching.